Alright, section 10.4, point slope form. Let's jump right in here, check out our objectives, and we're going to be graphing linear equations given its slope and point on a line. Use this point slope form to write the equation of a line. Use point slope form to write the equation of a line given 2 points on the line, and then we're going to learn about parallel and perpendicular lines. Okay, let's jump right in here, and I've kind of highlighted a few little spots here. Okay, we're going to graph the line with the slope m equals negative 3/4, which passes through the point 2,5. Now we're going to start from this point, okay, notice here, and we're going to locate another point on the line using this slope, okay. Now I'm going to jump to the next page here to kind of show you what this means. Notice, okay, that they're giving us the point 6,2. Whenever we use the slope, and I'll go and write that down for us again, we've got negative 3/4. Well, as it's stated, that's the same thing as saying negative 3/4 or 3/-4. It's not going to be a negative and a negative, okay, with this negative up front, which especially when dealing with slope, you want to make sure that that negative ends up in either the top or bottom. And technically speaking, personally, I always like it on top, but that's just sort of the mathematical, grammatical part of me thinking that. Okay, and notice when we look at this here, from 2,5, we can go down and then over 4. But from 6,2, notice we can go up and then negative 4. And it looks here that they've got a little bit of a mistype in there. That would be a negative right there. Okay, but this means that no matter what, we can go forever in circles right there. So let's take a look at what this means whenever we start talking about point slope form. Okay. An equation in the form y minus y1 equals m, x minus x1 is called point slope form for the equation line that contains the point x1 and y1. So notice whatever points they're giving us, we're just going to be putting those in at these points. And notice this guy right here, that's going to be our slope. Okay, so let's take a look at one of them. Okay, find the equation of the line with the slope negative 1, they forgot a line there, negative 1/2, and which passes through the point 2, 3. Graph the line using point slope form. Okay, point and slope, sorry. Substitute the values in the point and slope form. Okay, well, let's remember that the slope is going to be our m. Okay, and then it's giving us 2 points here. We're going to have x1 and a y1. So let's go and start filling everything in. Keep these y's right here. There's a reason that y is there. Okay, that you're not supposed to put anything in there or in here for the x. Just make sure to fill in your points, the y1 and the x1. So on your y1, we have a 3. So we have y minus 3 all equal to, well, what's our slope? Our slope is going to be this negative 1/2, which I'm going to make that a negative 1/2. Notice I'm putting the negative on top. Like I said, that's just kind of my thing that I do. And I've got x minus, well, notice I have 2 for my x value. Okay, that right there is in point slope form. So we can put this down, okay, point slope form. Okay, what you're going to want to do is you can get this into 2 other forms. You can get this into y-intercept, not y-intercept, I'm sorry. You can get this into standard form, or you can get this into slope-intercept form, which slope-intercept form is where technically you really want to get it, because then that gives you a lot of information. So let's take a look at this on the next page and see how this is going to look. So we've got, right now we have y minus 3 all equal to negative 1/2 x minus 2. Okay, there's our point there. Okay, well, what we're going to do is we're going to distribute this negative 1/2 out, and we're going to get y minus 3 equals negative 1/2 x. Well, notice I'm going to have a negative and negative. That's going to have a positive. These 2's are going to cancel, and that's going to leave me with a positive 1. Okay, let's go ahead and add 3 to both sides here. Okay, and when we get this into slope-intercept form, notice these are going to reduce out. You're going to end up having, in slope-intercept form, you're going to have y equals negative 1/2 x plus 4. Sounds great. Okay, sometimes though, you're going to want to get it in standard form, which, remember, that is of the form ax plus by equals c. Okay, so all we're going to be doing now, remember, slope-intercept form, you're basically solving for y. So to get it into standard form, just get the x back over to the other side. So we're going to add 1/2 x to both sides. That's going to give me 1/2 x plus y equals 4. But we don't want a fraction in here, so let's multiply everything by 2. And when we do that, notice here the 2's cancel out, and we're going to get x plus 2y equals 8. And now we match that form right there. And this also gives us a brand new point here. And if you look very closely at the slope-intercept form, we've got a point 0,4 there. And that, of course, shows up right here. I have to highlight here. Right there on the graph. And then our slope, which is right here, notice it goes down 1 and then plus 2, and it's going to keep going like that in perpetuity. No matter how long we just keep going, it's going to keep going and going in either direction, because I could even flip that negative to the bottom, and then I'd be going up 1 and then to the left 2. And so that's how we kind of create the line here. So let's continue on. Okay. Finding the equation of the line given 2 points. Okay, find the equation of the line given 2 points on the line. Use the formula. Notice we've got to go ahead and find the slope first, which is that right there. And where it says x2 cannot equal x1, the reason being is if those two equal, you get 0, and therefore you're going to have something that's undefined. Okay, use the slope m on either point. There, that is there. Just kind of what we've just done. So let's go back in here and let's do a couple more examples here. Okay, find the equation given the 2 points. Okay, first off, we've got to find our slope. So our slope, we're going to have, here's my x1, my y1, my x2, my y2, and I know my slope is going to be m equals rise over run, which is also y2 minus y1 all over x2 minus x1, which is going to equal, well, my y2 is going to be a -2. My y1 is going to be a 2. Let's put that all over. My x2 is going to be a 4. And then my y1, notice I have a subtraction and then a negative. Okay, make sure to do it this way. You still have to have that negative value in here and then your subtraction there. Well, -2 minus 2 is going to give me a -4. And then 4 minus -1, that's just going to be 4 plus 1, and that's going to give me a 5. So there's my slope. Now here's the thing. You can use either one of these for the next part. You don't just have to use your x1, y1 here. You just have to pick one point that you want to use and then run with it from there. So I'm going to go ahead and just pick this guy right there. And he's going to be what I'm going to put in point slope form. And then I'll I'll put him in y-intercept form. Okay, so let's come in here and I've got my y minus, well, my y1 is going to be this 2. All equal to, well, here's my slope, which is a -4 over 5. And then I've got x minus, notice I've got a -1 here. Put that right there. And then close off the parenthesis. Okay, now what I'm going to do is I'm going to start distributing everything. But I guess I could simplify the inside of that real fast. I could put y minus 2 equals -4 over 5. That's going to be an x plus 1. Okay, well, let's go and distribute this guy out. And we're going to have y minus 2 equals -4/5 x. Well, that's just going to be multiply everything by 1. And notice I've got a negative here. So it's going to be minus 4/5. Okay, let's go ahead and add this 2 to the other side. We're going to take this 2, add it to both sides. Okay, well, that's going to be a 2 over 1, but notice I'm going to have to multiply this guy by 5, okay, because I want to have common denominators here. So then I'm going to have y equals -4/5 x minus 4/5 plus 10 over 5. Okay, and then we're rounding off to the end here. We've got y equals -4/5 x. Okay, well, -4 plus 10 is going to give me a +6. So that's going to give me a 6/5 fifths. And then this right here would be in y-intercept form. So notice we have a slope-intercept form. I always want to say y-intercept. I don't know why. Notice we've got our slope here, and then also notice that we've got a point at 0, 1, and 1/5 is where that point would be at. Jumping over here to the next page, you can see how this graph would look here, and there it is right here. Let me come in here and I'm going to rewrite our solution. We've got y equals negative 4/5 x plus 6/5. I also want you to notice here that what we also could have, okay, is I can change this into standard form if I wanted to. I can come in here and go, okay, well, let me go ahead and add 4/5 x to both sides, and that's going to give me 4/5 x, okay, plus y, all equal to 6/5, and I'll go ahead and multiply everything here by 5. Remember, standard form, you don't want to have fractions. Okay, you can't have fractions. Okay, multiply everything by 5, and that's going to cancel the 5's out here, leaving me with 4x plus 5y equals 6, and that would be the equation for this line in, this is standard form. Okay, and that's how that would look there. Okay, now let's go ahead and jump into parallel and perpendicular lines, okay, because they're going to become very important, especially moving forward. Okay, parallel lines are lines that never intersect and who have the same slope. Okay, remember this would be very important. Same slope right there, okay? Perpendicular lines are lines that intersect at 90 degrees or 90-degree angles and whose slopes are negative reciprocals of each other, okay? So I'm going to give you an example what a negative reciprocal is. Let's say we have m equals negative 1/2. There's our slope, okay? The negative reciprocal of this, or the reciprocal, so that way we have a line that's going to be perpendicular, will literally be invert this guy, so, and then well, if this is negative, make it positive. You're literally just going to make it the exact opposite. So your negative, okay, I'll just go ahead and abbreviate that, is going to be 2, okay? Because if I flip this guy, that makes him 2/1, okay? And then if he's negative, I make him positive. You're literally making him the exact opposite. I've never really liked the terminology of this, but that's how you do that. Okay, note all vertical lines, undefined slopes are parallel to one another. All horizontal lines, zero slopes, are also parallel to one another. And let's look here. Find the equation of the line through the point 3, 2 and parallel to the line 5x plus 3y equals 1. Graph both lines. Okay, we're looking for one that's going to be parallel. Okay, so let's be very careful and let's start working this out. Okay, notice that this right here, I'm going to put it in red, that this is in standard form. Well, it's really hard to tell what the slope is going to be in that, so I need to go ahead and resolve for y to find out what the slope is of this guy, okay? And that'll become very apparent very quickly why I need to do that. So let's do 5x plus 3y equals 1. Well, let's go ahead and subtract 5x from both sides. Okay, that's going to give me 3y equals negative 5x plus 1. I'm going to divide off of 3. Okay, and I'm going to get y equals negative 5/3 plus 1/3. Don't forget my x there. Okay, I just found out the slope of this line. Okay, well remember, for this, now I need to create a new equation. Well, I have a slope for that new equation now, and since it's going to be parallel, I want to make sure it's the same slope. So I have me a slope that I need right now, a negative 5/3. Okay, now let's take this guy here and let's plug it into our point slope form. I'll do that in black. Well, I've got this x1, I've got this y1, so let's do my y minus 2 equals, here's my slope, my negative 5/3, and then I've got x minus 3. Okay, continuing on, I'm going to go ahead and have this y minus 2 equals, I'm going to multiply, I'm going to distribute this guy into there, and I'm going to have negative 5/3 x. Okay, well, notice whenever I've got a negative and a negative, that's going to give me a positive. The 3's are going to cancel, and that's just going to give me a negative 5, or sorry, a positive 5. Let's add 2 to both sides. That way these reduce out, and I'm left with y equals negative 5/3 x plus 7. So this right here, what this does, notice same slope, okay, that creates parallel lines, okay. Using this point though, this is going to be a totally different equation, but this equation will, this line right here will be parallel to this line. And if we look very carefully here, notice this line here has a y-intercept of 0, 1/3. This one has 0, 7. Well, let's take a look at the graph. And here we have it. We can see that our first line here, notice it kind of goes past right there at 0, 1/3. And if we continued this line up, which I wish they would have on this one, we can see that this is going to go through at 0, 7. And that's exactly how this is going to just keep working and working and working, just like this. You'll do perpendicular lines the exact same way, which we'll do some of those in Hawks. And let's jump down here real quick just so we can kind of remember some of the properties. That way you just know that these are at the very end of your lesson. Notice here we got standard form. Here's just some properties, some formulas that you're going to need to remember. Okay, but these are all going to become very, very, very much just kind of just part of your muscle memory. Eventually, you're going to do so many of these. So let's do some Hawks examples.